Okay, so let's review some things. Now, when we label triangles, vertices are uppercase letters, okay, and sides are lowercase, and they're always opposite the angle. So opposite side A is angle A, opposite angle B is side B, opposite angle C is side C. When we are writing angles, so if I'm writing angle A, there's two ways we can write angle A. I shouldn't say angles A, just angle A. Okay? One way is you might see it just with the angle symbol and A. Angle A. That's one way. Another way it might be written is angle BAC, or you could also write it as angle CAB. So notice the A is in the center, and what you're saying is the angle made when you go, if you're saying BAC, the angle made when you go from B to A to C, what is that angle? It's included, BAC, or CAB, right? Same thing, C to A to B, that's our angle A. Okay, sides, we can either write them to, if I'm talking about side A, it'll literally be lowercase a, or sometimes they write it as side BC. Okay, it's the same thing. Side BC is lowercase a. It's the same thing. We often use theta for an unknown angle. It's called theta. And you're probably used to that one. Isosceles triangles. What's an isosceles triangle? Close. That would be an equilateral triangle. Two sides are equal. Okay, so if two sides are the same, that's an isosceles triangle. So for example, if this had a 40-degree angle, how could I find, what do we know about those two bottom angles then? They're going to be the same, and they're going to have to add to 140. So what would they have to be? It would be 180 minus 40 and then divide by 2, because we know angles in a triangle add to 180 degrees, right? All angles in a triangle add to 180. Doesn't matter what type of triangle, it'll always add to 180. And so if these two sides are the same, then their sides opposite, their angles opposite those sides must also be the same. And so if we subtract 40, divide by 2, they should be each 70 degrees. Because they have to be the same, and we know that they all add to 180. All right, opposite angles are equal to each other. So if we have X's and O's there, right? Opposite angles are equal. If we have parallel lines, corresponding angles, we call these corresponding angles, are equal to each other. Okay. You'll probably see parallelograms a few times in this unit, especially if we're talking about the diagonals of a parallelogram, and we can turn it into a triangle. But one of the properties of parallelograms is that these two angles add to what? Oh yeah, sure. Oh wait, sorry if I'm too fast. Okay, properties X and O, what do they add to? Nope. Okay, what do the angles in a quadrilateral add up to? If a triangle adds to 180, do you know what a quad adds to? 360. 360, yeah. In a parallelogram, these two angles then would add to 180 degrees. okay? So angle X and angle O add to 180. And what we call that, whenever angles add to 180, they're called supplementary. So those would be supplementary angles. Supplementary angles add to 180. Okay, so in a parallelogram, X and O will always add to 180. A square is a type of parallelogram, right? And all the angles are 90. And so X and O still add to 180, 90 and 90. All right. One more thing, a straight line. What's the angle for a straight line? 180 degrees. Good. So often we look at, like if there's a line in there, those could be supplementary angles because if I had an extra line, this angle here plus this second angle are supplementary, right? They're going to add to 180. So, okay, turn the page. Let's see how that down. Okay. What's really important to remember about the Pythagorean theorem? Some things. There's a couple things. It's only for right triangles. So what's a right triangle? Has a 90 degree. Yeah, has a right angle. I can't tell you how many times I've seen students try and use Pythagorean theorem on a triangle that does not have a 90. It breaks my heart. Okay? Why? This is so ingrained into you because it's all you've ever studied. All you've ever seen are triangles with a 90, or you made a 90 and then where it's like it's built in somehow, right? That only works for right angle trigonometry. Guess what? Are we focusing on right angle trigonometry this year? No. Will it show up sometimes? Yes. And so those, we need to review it because sometimes it might show up, but rarely. Mostly our triangles that we're going to deal with are going to be acute triangles or obtuse triangles that do not have a 90-degree angle. And so we're going to have to use a whole another set of skills to find sides, the lengths of sides and angles. Okay, so the main thing is that it's for right angle triangles. It's really important. Right angled triangles, yeah, I guess so. Kind of sounded weird. C is always your hypotenuse, right? Now, it always lands where? How do you know where C is going to be? Yeah? It's right across from the 90, and it's the longest side. And the reason why it's the longest side, it's really important to remember that the largest side is across the largest angle. And the same is true for the smallest angle and the smallest side. They're always across from each other, right? If you make a small angle, the side opposite of you is going to be very small. Big angle across from you, very big. And so when you are asked questions like solve for the smallest side or solve for the smallest or largest angle, you need to know where that is based on your measurements. The largest side is across the largest angle. Smallest side across the smallest angle. The middle side is across the middle angle. Okay? All right. Because we are in grade 11 and we're in 20-1, we can adapt our formula to be a little bit more beneficial to us. So if I wanted to find C in one step, how could I type it in my calculator? Square root of a squared plus b squared. So we can push square root and then go a squared plus b squared. And we can find it in one step. Say I was solving for side A. How could I find side A in one step?
Square root of c squared minus b squared.
It'd be c squared minus b squared. If we're solving for a or b, which is not the hypotenuse, then we have to take our hypotenuse squared and subtract the other side squared. And we can type it in all at once using, and then push square root, right? type it in all at once. We should be able to do that now. We're in 20-1. We've seen Pythagorean for a couple years now. It should be getting to the point where it's like, okay, let's do this quickly. Okay? All right. So let's solve for x here. Now again, Pythagorean theorem only works for the right triangle, so we have two right triangles here. We have to start solving for y because we don't have enough information for x. Okay? So, y is equal to the square root of what? Who's your hypotenuse? 9. That's my c. So it would be c squared minus b squared. 9 squared minus 6 squared. Okay, calculators. Let's talk about a few things. Second square root is a second x squared button. 9 squared minus 6 squared. Okay. So we get 6.708. One of the biggest, so I'm going to write down 6.7 for y. But are we going to use 6.7 in our calculations? No. And if you're in physics, you're probably used to this as well, right? We are going to keep in our calculator, keep in calculator, and use the exact value. We only round at the very end. I might write down 6.7 or 6.808. It doesn't matter what I write down. The key is that I use the exact value in my calculator. And there's two ways we can do that. We can either use the answer button. Okay, where's the answer button? Second, negative. Okay, second negative is one way. The other option is we can actually store the number. Either method works. It's really up to you. If you want to store it, what we want to do is push the store button. Now the store button is really handy, especially if you're dealing with a type of problem where you're going to have multiple numbers that and instead of you're like, I only can use answer once. That's an issue. Storing is really beneficial. We push the store button, which is STO, and it's right above on, and then we choose a letter. Okay, so the letter we choose is going to be, I'm going to use Y. How do I get Y? Alpha 1, alpha 1. So now I've stored, if anytime I type in Y, it's 6.70821, the exact value. Okay, so storing numbers work, or you can use the answer feature. They both work fine. Okay, so store the number, we push the STO and choose a letter. So often I use X, the X, T, theta, N button personally, but because we have X and Y in this question, I chose Y and then enter. Okay, so now we can solve for X. In this right triangle, X is our hypotenuse, our C. So we can go square root of, I'm going to write 6.7 squared, but I'm actually using the exact, right? Plus 3 squared. So when we type this in our calculator, we're typing in, we have two options. If we use the Y that we stored, I can type in square root alpha 1 squared, so Y squared plus 3 squared. Okay, and there it is. So there's the exact. The third option you have is always go to 6 decimal places. If you always go to 6 decimal places, you'll be good. You always use 6. That's the other option. Okay? 7.3 is our answer. Just going to check if it changed our answer. If we, guessing it won't in this case. It doesn't?
It's like 3.40.
Yeah, so this question we're safe, but you won't always be. Yeah, you won't always be. Okay, do you want to try 2 on your own? No? Okay. A square. Start by drawing a square. We already said earlier today, squares have angles of 90 degrees. That's supposed to be a square. It doesn't really look like one. What is the diagonal? Okay, and where do I draw that? Across, yeah, corner to corner. In a square, the diagonals will be the same length. Later on, we'll deal with parallelograms. Would those diagonals have the same length? No, you'd have a shorter one, and then you'd have a longer one. Okay, so there'll be times where you might be asked on a test to solve for the larger diagonal, or the smaller diagonal. Okay, but that's not today. Okay, how can we solve for our side length? Okay, you're using, oh yeah, so you could do that. Good old trick. Okay, how can we use Pythagorean theorem? So you could do that. That's totally legit and good mathematics. So you're saying, okay, we know it's a 90 and it's a square, so that has to be 45 and 45. So I can use my awesome trig skill, the SOHCAHTOA, and solve for that side. Okay? You can use Pythagorean, and I'm going to just show you how. Just because it's a Pythagorean question. For funsies. So c squared equals a squared plus b squared, or 13 squared equals x squared plus x squared. Okay, can we add x squared and x squared together? Yes. How many x squareds will I have? 2x squareds. 1x squared plus 1x squared equals 2x squareds. So then what? Divide both sides by 2, which gives me 84.5, I think. Question? Okay. Said 84.5. And then do what? Square root both sides. And we get our answer of 9.1 decimal place, 2 meters. Okay. So you didn't have to, you can use trig. You'd use adjacent and hypotenuse, so cosine. That's one method, but you don't have to. You can use Pythagorean to solve this, but you just have to do some algebra. Okay? All right, let's look at the next page. Okay, everyone's favorite, SOHCAHTOA. Some of you might have your own little way of remembering this. Yeah, no. You might have heard some horrible ones. SOHCAHTOA is usually the most common. My 10C class last semester had a very interesting way of remembering it. I don't like saying it though. Okay. SOHCAHTOA. Now, again, what's really important here, it's only for right angle triangles. This does not work. You cannot use SOHCAHTOA if you do not have a 90-degree angle. Got it? Only for 90-degree angles. Okay, so some review. If this is my, oops, that's not a pen. If this is my angle theta, here's my 90. When we label our sides, where does the hypotenuse go? We already talked about this. Across the 90, right? The largest side is across the largest angle, which is the 90. Side opposite of our acute angle. So it's always in reference to one of the acute angles. What's an acute angle?
Small.
Smaller than 90, right? It's adorable. Yay. It's a cute angle. So that's side opposite. What does the word adjacent mean?
Parallel.
Beside. Adjacent means beside. And that's because it's the other side that's beside the angle. So the hypotenuse will be beside the acute angle, but so will the side adjacent. Adjacent means beside. If I'm adjacent to you, we are beside each other. Okay, so if I want to find the ratios, the following triangle, the measured lengths of the sides are labeled, determine the following ratios. If I want sine of A, I'm not looking for the angle, I'm just looking for the ratio. The ratio for sine is opposite over hypotenuse. But that's in reference to angle A. So in reference to angle A, what's the side opposite? 3, 4, or 5? 4 divided by 5. Hypotenuse is 5. Okay. Cosine is adjacent over hypotenuse. So in reference to angle A, which one's adjacent? 3. Hypotenuse is still 5. Hypotenuse never changes. Doesn't matter which angle, acute angle you're talking about. Okay, and tan of A is opposite over adjacent. So opposite of A, 4 over adjacent of A, 3. Okay? So does everyone know how I got those numbers? Yeah? Okay, for angle, the ratios for angle C. So again, it's opposite over hypotenuse, but this time we want opposite of angle C. What's opposite of angle C? 3 over 5. Okay, so looking at angle C, this is now my side opposite. Here's my hypotenuse, here's my adjacent, in reference to angle C. Okay, cos is adjacent over hypotenuse, so adjacent to C, 4 over hypotenuse 5. And last tan, which is opposite over adjacent, opposite to C, 3 and 4 for its adjacent to C. Okay, so those are the ratios. Usually in 10C, where students would make their mistake is that if a student was asked to solve for tan A, you'd want to do fancy stuff. Like it's just the fraction 4 divided by 3. That's the ratio. That's tan of A. We're not looking for the angle or anything fancy. We're just looking for the ratio. So when we're solving, we need to draw the triangle, label the sides opposite, adjacent, hypotenuse, and determine which trig ratio we want to use. If you are given a ratio and we're looking for the angle, that's when we use the inverse function. Okay? We use the inverse when we are looking for an angle. So whenever you're looking for an angle, then we use the inverse. So to find the angle, that's when we use the inverse trig functions. Okay? What mode does your calculator need to be in? Degree mode. So let's all check that. Okay, so calculators. We want to push mode, which is beside second. You want to push the down arrow twice, the right arrow once, and then you push enter. And degree should be highlighted. Okay? There is a way to check to make sure you are in degree mode, and that is tan 45 degrees. Tan 45 should always equal 1. Oops, I'm dyslexic today. TNA. Tan 45 equals 1. Okay. So if tan 45 equals 1, then you know you're in degree mode. If it equals 1.6, then you know that you are in radian mode. And radians is another way to measure angles that you will learn about in Math 30-1. Okay? So you've spent your whole life understanding degrees, and then you'll have to learn another way to measure angles, which is in radians. Yay! But not till next year, so we can relax. It's okay. That's another day, another time. Okay. So, if I want to find angle A, what we're really doing is we want to get rid of the tan. And how we get rid of tan is we're taking the inverse of both sides. So you don't have to write this step down, but you can if you want. So this is what we are mathematically doing. We're taking what you do to one side, you do to the other. And the inverse tan of tan is they cancel each other out. You're just left with your angle because they're opposites of each other. And so they cancel each other out. And so that's where this comes from. We do this to both sides. In mathematics, we always have to keep equality. And so to get our angle, we inverse both sides. And how do we do that in our calculator? Oh, darn. Second tan. Yeah. So second tan. That's how we get the inverse of 1.57 gives us 50 to the nearest degree. Let's go. 58. Okay. So the ratio can be written as a decimal or a fraction, but it's the same idea. To get the angle by itself, move the cos to the other side. We have to inverse both sides. So second cos 2/3. Whenever we're looking for our angle, that's when we use the inverse function. Okay, 48 degrees. All right, last page. Okay. We're actually gonna only look at examples 3 and 4, and then we'll call it a day. So we can get through the rest. Maybe we'll do 5. No, we'll do 3 and 4. Solve the triangle. What does it mean to solve a triangle? Thank you. Guys? Okay, find all unknown angles and sides. All right, so let's draw this triangle. It says given angle E is our 90 degrees. Angle D is 24. I'm going to put D down here because that's my smaller of the two acute. And side EF is 7.2, so that must be F. EF is 7.2. Where do you want to start? Should we find angle F? That would be the easiest, so let's start there. Why is it easy to find angle F? Perfect. We know that angles in a triangle add to 180, and we know 2 of them. So we're going to take the 180, subtract the 90, and subtract the 24. And what's left over is 66 degrees. Or you can add 90 and 24 together, then take it away from 180. It's the same idea. So angle F equals 66. Right? Another thing that's true in all acute, in all right triangles is the 2 acute angles will add to 90. Right? Because 90 is already taken, so those 2 add to 90. So just 90 minus 24 is another way to get it. Same idea. Okay, let's solve for ED or DF. Which one do you want to do? ED. Let's call that X. Okay, so we're going to label our triangle based on our 24 degrees. Even though we know this is 66, I'm going to use the 24. It's always safer to use the given angle just in case you made a mistake. Somehow adding happens. You know, it does happen. So use the given angle if you have a choice because it's safer. Let's label. 7.2 would be side. Or side EF is what? Opposite, adjacent, or hypotenuse? Opposite. And the side we're looking for, ED, would be side adjacent. So which ratio do we want to use? Tangent. Right? O and A is tangent. We want O and A. Tan of an angle is equal to opposite over adjacent. That's our formula. So tan, subbing in what we know, our angle is 24, equals 7.2 over x. Okay, we have some review to do. We have a problem. Problem is that x is on the denominator. How do we get it off the denominator? Multiply. It's like cross multiplication. Yeah. You can think of tan 24 as being over 1. Right. And so it's like we're cross multiplying. We want to multiply both sides by x is essentially what we're doing to get the x off the denominator. Or think of it as cross multiplying. So we have x times tan 24 equals 7.2. Right? Because we're multiplying both sides by the x. Another way to think of it is we're multiplying both sides by x to get the x off the denominator. Or you can think of it as cross multiplication. Same idea. Okay? Now what's our next step? Divide by, I heard it, tan 24. 1x by itself. And so most of you probably went straight to the shortcut. When you had tan 24 equals 7.2 over x, you know it, your x and your tan 24 switch spots, right? When you're solving for the denominator, you're dividing by the tan of the angle. When you're solving for the numerator, we're multiplying. Okay. So 7.2 over tan 24, and let's go to 1 decimal place. 16.2. Okay, and actually instead of calling it x, I'm going to call that side ED. I just called it x for the calculations, but it's side ED. What's the easiest way to solve for side FD? Pythagorean theorem. So it's the hypotenuse, so we're just going to go square root of the 7.2 squared plus the 16.2 squared. What's really important here when we type this in? Use the whole number. Remember, we're going to use the exact for the 16.2. Use the. Let's try that again. Use the exact number. Oh, you can't see that. Sorry. Okay. So, easiest way would be square root 7.2 squared plus my answer, which is second negative squared. So it looks like that. 7.2 squared plus your answer squared, which gives us 17.7. Okay, not so bad. Here, I'll leave that up for a second. Oops, where'd it go? Okay, while you're waiting, can you draw the next picture? So read through the question and then draw the image. This is the fun part of trig, especially if you enjoy drawing. If you loathe it, then I'm sorry. Now, obviously, 2 degrees is really tiny, so we're not drawing this to scale.
Are you assuming that the towers will stand up straight?
Yes, that's another assumption we're going to make. I feel like it's a kind of a safe assumption because most things that are built usually stand up at a 90, perpendicular to the ground. Yeah. Okay, so we know that the tower is 20 meters high. We are assuming that it's perpendicular to the ground and it's not the Leaning Tower of Pisa. Okay? That would be a bad situation. We do not want our buildings and towers to lean. It says the angle of depression is 2 degrees. Now, the biggest part where students make mistake is the angle of depression. Most of you are good with angle of elevation, but angle of depression, no. I don't know what happens, okay? The key is that angle of depression is from where to where? Where do we have to start? The top, right? What do we call that top line? It's a horizontal line. So we always start from the horizontal down to the line of sight. Okay? So here, there's a horizontal coming out of his eyes. It's like he has lasers. Lucky guy. Okay? So angle of depression is from the horizontal down to the line of sight. Okay, so line of sight is where he's actually looking. Is our fire. So angle of depression would be this angle here. From the horizontal down to the line of sight. Now here's a secret. I'm not sure if your grade 10 teacher told you this. It might have helped you. Angle of elevation is the same. If they give you the angle of depression, you also know the angle of elevation, which is from the horizontal up. So this is also 2 degrees. Okay, those are always the same. Crazy. Okay, a common mistake is a student likes to put angle of depression up in that corner. No. What you should do is just change your angle of depression to an angle of elevation, and then you always have this angle, and you're safe. And you can use that bottom triangle. And the reason why it's like that is because we have 2 parallel lines. These are parallel to each other, and these angles here, this one and this one, are what we call interior alternate angles. Do you remember learning about that? Some of you know. Like the Z? No? Z. So the Z, these angles here are called interior alternate, and they're always equal to each other. Back in the day? No? Yeah? Some of you? Maybe not? Okay. Doesn't matter. Doesn't matter. Key is that you know this, that elevation is the same as depression. So now can we find the distance away from the towers from the fire? Yes. So I'm going to use the bottom triangle. I like it a lot more. I feel like the top triangle is just not natural. I don't know. Just how I feel. I have a bias. I'm biased to the bottom triangle. Alright, so this is opposite. X would be called the adjacent. What ratio has O and A? Not very exciting. Again, tan. TOA. These formulas are on your formula sheet. SOHCAHTOA is on there. So you don't have to memorize it. Pythagorean is not on your formula sheet. That one you should kind of know by now. Okay. So tan 2 degrees equals opposite of 20 over adjacent of x. This is the same thing as tan 2 over 1. So if we cross multiply, we get x tan 2 equals 20, and then divide by tan 2. Now this is going to be a huge number because 2 degrees is really tiny. 572 point. So 7. Let's go 1 decimal place. Oh no, it says 2 decimal places. So 7. 3? Thank you. That's pretty far. Half kilometer-ish. Got good eyes. Okay, the last thing I want to mention, I'm actually going to skip the angle of depression question. Just really quickly, if I have a triangle, and say I have this angle down at the bottom is 30 degrees, the hypotenuse is 15, and I'm solving for this side over here, x. Okay? Which ratio would I use? X is called? Yeah, you'd use sine. Opposite hypotenuse. So you would use sine of your angle equals x over 15. This is like over 1. So to get x by itself, all you have to do is what? Times both sides by 15, right. So we just need to get rid of the 15, so we multiply both sides by 15. So if x is on the numerator, life is easy. 15 times sine 30. 7.5. Beautiful. Okay. All right, so your assignment are the 2 handouts. Now, there's a lot there. If you feel like you're getting a question and there are a lot of the same, skip that and move on to the next. Right? Do what you need to do to make sure you are comfortable with grade 10 trigonometry, SOHCAHTOA, Pythagorean theorem. Okay?